First we add x to both sides. Then we'll have isolated the square root and we can square both sides to get rid of the radical there. So that's the plan. So x squared plus 6 under a square root then is equal to x plus 4. And now if we square both sides of the equation, we get rid of the radical. Have to square both sides. And on the left we get x squared plus 6. The radicand is freed from its being trapped under that radical symbol. And over here we have x plus 4 squared, so that's x squared plus 2 times 4 times x. 2 times x times 4. 2 times this is 2 times 4x is 8x. Plus 4 squared is 16. To solve this, notice that I can subtract x squared from both sides, and it's no longer a quadratic equation, it becomes a linear equation, which we can now just solve for x. So let's subtract 16 from both sides while we're at this to isolate the x term right here. The left side we end up with 6 minus 16 is negative 10. On the right side all that's left is 8x. So now if I divide both sides by 8, I will have solved for x. For the 8's cancel, and you're left with negative 10/8, which is negative 5/4, is equal to x. We still have to check that if this really does work in our equation. So let's now check this. See if it works. So is it the square root of negative 5/4 squared plus 6, then minus negative 5/4? Does that add up to 4? Does that really add up to 4? Well, this becomes 25/16 plus 6 under the square root sign here, plus 5/4. We're wondering, does that add up to 4? And if we find a common denominator in here, we have to multiply 6 times 16, which is 96. So this is 96/16. So we can add the two numerators. 25 plus 96 is 121. So we're wondering, does that add up to 4? And the square root of 121/16 is 11/4. And 11/4 plus 5/4 is 16/4, and that does equal 4. So our solution is valid. It actually solves the equation.